Welcome, everyone, to this morning's ANRA Huddle. Thank you so much for being here. I'm Miriam McNabb, editor at Drone Life, and I will be moderating this panel today. Just give us one more minute and we will get started. All right, before we begin the session, I want to point out a couple of things about the platform that we're on. You will see at the bottom, and the last 15 minutes, our moderators will enable the question button. Please do submit your questions through that, and we will save the last 15 minutes to respond to questions from the audience. We would ask that you save those up until the end. We may address them during the course of our discussion. So again, thank you for being here. It's always kind of a privilege for me to moderate these panels of experts. Today, joining us, we have representatives from every aspect of the question of vertiports. So we have Brent Clavon with ANRA Technologies, representing the digital connection between the aircraft and the infrastructure on the ground. We have Chris Hill from the Helicopter Association International to represent the manned aircraft discussion and perspective. We have Anthony Tesla from Supernal, one of the leading developers of eVTOL vehicles, who will be utilizing these vertiports to serve communities around the world. We have Ian Coots. Sorry, I'm running out of breath here. We have Ian Coots of Arcadis, who is a consultant and engineer developing those physical structures. And we have Ty Leroy, who is an impressive pilot. He can pilot any kind of high stakes aircraft, and he is responsible for developing, through his company Navos, developing the flight procedures in and out of these structures. So, let's get started here right away with a kind of discussion that sets the stage for why we need to develop vertiports in communities. So I'd like to start with you, Anthony. You have spent over 25 years in aviation planning, aviation project management. Now, of course, you are with Supernal, but one of your specialties of expertise is, of course, working with high capacity airports and structures that are of challenging access. So, talk about some of the use cases that Supernal sees for eVTOL aircraft in the future.
Sure. And yeah, thanks for having me on. It's been an interesting career with lots of different changes, and it's a great time to be involved in aviation at this point. A lot of the technologies and efforts are all coming together, and in order to kind of create a systematic view of the future of urban air mobility. It's important to point out that Supernal is just an OEM, so we're planning on putting our emphasis into the vehicle and competing on all the various areas that an OEM would typically be involved in. So the vehicle could be deployed on any number of use cases that we're thinking about, and even many others that we may not be thinking about. But I think the one that we're thinking will involve the ability to scale is certainly going to be the urban air mobility concept, which is essentially the air taxi effort. And Supernal's angle on that is that it's part of Hyundai's overall introduction into service as a or mobility as a service. So the idea would be you'd be able to use your device and be able to travel from point A to point B using a variety of interconnected options, such as vehicle, ideally being operated by Hyundai, and aircraft, and potentially other forms of mass transit. And that would require a fair amount of infrastructure to be produced, from electric charging to vertiports throughout the cities, access to airports, particularly the busiest airports that operate, and an ecosystem to support it in order to bring the air traffic control system down into the city street level and to smooth out the connectivity that occurs as the aircraft transitions from the urban environment to the en route phase, which would require interaction with the existing system and other users. And then beyond that, there's a variety of other types of use cases, many of which I think are essentially replacements of existing helicopter and aircraft. And those types of use cases may not be of the scaled variety, these replacement types. And so some of those may not require significant changes in the infrastructure other than electric in order to operate. They may be able to operate more or less in the existing air traffic control environment, but they're still very important to us and the others involved in urban air mobility in order to kind of improve the vehicle's use, as well as the ability to as well as to get feedback on the operation of the vehicle and important feedback on how to adapt to it.
So is it fair to sort of call this a concept of intermodal transportation, where you go sort of for whatever type of transportation is most appropriate for the distance that you're traveling, and you kind of want to link those together, or is that not the phrase that you use here?
Yeah, it's interesting. So I've been involved in intermodal, and I guess I just personal preference. I started to hate that word after a while because it kind of indicates like you feel like there's a blockage when you get to the nodes that require you to switch over. And I think the emphasis where we have on mobility is that those nodes are sort of seamless. So you're managing your whole trip as opposed to managing a segment of the trip that gets you to the next node, and then you have to deal with the segment that you're dealing with later. So I've kind of dropped the intermodal part of it off and now start to think about having a smooth and efficient and safe form of transportation in its entirety, as opposed to a safe and efficient aviation segment of it.
Right. Okay. Great. So I guess you've just introduced sort of a great segue to Brent, right? Brent, you've worked in aviation for many, many years, starting, of course, with the military and then transitioning. You were also a pilot, both manned and unmanned. And with your work at ANRA, you're really responsible for this concept of how vertiports will connect to the broader network, sort of enabling VTOLs to transit between nodes, including vertiports and heliports. So what's the concept there of how this will work?
Thanks, Miriam. And I do want to take issue with you before I begin. I noticed there are 4 pilots on this panel, and only Ty was called impressive. So I'm not sure how that happened.
It's the Apache thing. When you put Apaches, flying Apaches, you're all very impressive. I am personally impressed by all of you.
But to answer your question about the broader ecosystem and connecting to it, I do think that is something that is probably the least understood and least represented at this stage in the development of urban air mobility type of technologies. And I'll explain why I say that, because there's a heavy emphasis on the thing that we understand, I think, the most, which is the aircraft, and understandably so. There's a lot of effort, a lot of time, a lot of energy, a lot of press and media pointing towards the aircraft, which is one piece of the entire ecosystem. And I'm not diminishing that at all. In fact, I had the pleasure of being at CES with Tony last week at Supernal's unveiling of their SA-2 aircraft, beautiful aircraft. And we want to enable those aircraft to fly from these nodes, as you described it, whether it's a vertiport, airport, or a combination of these, and then expand that network to multiple locations and destinations. But how do they get to these places is what you're referring to. And so there has to be some digital layer that allows the aircraft that will become increasingly more autonomous to be able to exchange data with all the actors in this broader ecosystem. And some of the actors include air traffic control. Some of them include the destination and arrival locations and departure. It also includes other fleet operators that are within that system that would have to be strategically deconflicted from each other. So as they fly through that airspace, these increasingly autonomous aircraft don't bump into each other. And so there's a lot of different services that have to exchange information, and the information has to be standardized. There have to be protocols so that the right piece of information gets the right individual at the right time. And so as automation increases, the services that support and enable these aircraft and these missions and operations, so too will have to increase. And so connecting a vertiport, connecting an airport, there's the in-route portion, and there's also the portion that gets you to the destination, and that too will have to be connected and sharing information. So when Supernal aircraft wants to take off and fly to Los Angeles Vertiport A, a place and a pad waiting for them at that destination, and there's no conflicts in between. And that's what we hope and others are going to help develop that digital layer to enable those activities.
Okay. And now I'm going to sort of move to Ty, right? Because you're talking about sort of the digital preparation, really make sure that there's a place for an aircraft to land and to take off. And Ty, you're responsible for developing, FAA approved flight procedures and evaluating those. You were actually, I believe, instrumental in getting FAA approval for the first vertiport site in Virginia recently. So can you talk about how that fits into the whole thing? And we are sort of moving here. We have representatives, as I said earlier, from each aspect of the problem. So then we'll ask Ian about the physical, and we'll talk to Chris about that transition between manned and unmanned. But Ty, what are you considering when you're thinking about these flight procedures in and out of vertiports?
Yes, ma'am. So I do instrument flight procedures, and so that's centered on operating in bad weather when visually you can't avoid obstacles. So we're one of the few people authorized by the FAA to survey those paths through the clouds. And in doing that, we have to use some proven mathematics for distance from obstacles. And so with these unique designed aircraft, that invisible infrastructure that we build, allowing aircraft to fly in the clouds, is based off of certain variables such as airspeed, climb gradient, angle of bank, things like that. And so for a helicopter, which is a lot slower, in the final approach and the missed approach segment of these procedures, we can get them closer to obstacles while they're in the clouds. So they can, operate in places that are not airports that tend to be more cluttered with obstacles. I built and fly procedure to my local trauma center, and there's big towers and a mountain behind the hospital, and we pop out of the clouds and all of it's right there. And I can do that because my aircraft is slower than an airplane, right? Well, a human being that's flying a helicopter by hand cannot hover a helicopter in the clouds. You need those visual references, right? So the slowest I can go is 70 knots. These particular aircraft that we're talking about for urban air mobility will be able to hover in the clouds. So because of those slower airspeeds, we anticipate that we'll be able to build procedures that let them get even closer to obstacles in the clouds. So that's the work and the talent and the capability that we bring to this, is that we can build unique IFR procedures for new machines and make that safety case to the FAA, for approval. The other thing is that, surveying vertiports and then getting FAA approval, pouring the concrete and, the physical building of these things is incredibly important. Integrating them into the national airspace system, assigning them an identifier so you can issue NOTAMs. Charging station goes down or something like that. There has to be a way to notify users, of alerts centered on the landing area, assigning radio frequencies, so integrating a vertiport into the national airspace system is kind of what we offer, and that's going to have to happen. And especially, as we transition, from manned to unmanned, we're going to have to tie these into the existing airspace system as we transition forward. So.
think you need to unmute yourself.
Sorry
Mary.
about that. Sorry about that. I want to move over to Ian at this point and talk about that physical infrastructure, because you are heavily involved in sort of establishing what actually has to happen on the ground, the physical. And as Brent pointed out, there has been a lot of focus on the aircraft themselves. There's also a certain amount of focus on the design of vertiports. They're often sort of portrayed as these sort of beautiful structures, but that's just what they look like. What are the components unique to vertiports that you're trying to consider and design for?
Yeah, thanks, Miriam. So we're looking at the ground infrastructure aspect here, and when we're going to start scaling up vertiports, I think building them at airports is going to be the relatively easier part of it, because we've got existing they're existing kind of professionals. They've got systems in place for traditional aircraft, helicopters, whatnot. So it's it's going to be relatively simple compared to other vertiports to integrate them into airports and into existing systems, such as digital systems, such as into air traffic control. Where the problem will be is when we expand this onto, for instance, the roof of buildings and car parks, hotels, as an example. Then you're looking at operators who don't traditionally operate airports or aviation assets. So it's more difficult there's the precedent hasn't been set there, so it's a bit more challenging. But from an actual design perspective, there's the FAA have released guidelines on that, so have other places around the world, such as EASA. So the standards are developing, and as a company like Arcadis, which we're heavily involved in airport planning and design, it's not so much of a stretch to then convert that to vertiport planning and design. The physical ground aspects for building it's basically really a new type of airfield with aprons, taxiways, and whatnot. The challenge is then integrating it in with operators who've never really experienced operating in aviation before. Although there are lots of ways around that, and there's also lots of companies out there that are doing it. And then I think Anthony mentioned intermodal transport, or the word intermodal. I won't use that, but maybe I'll use integrated instead, where a company, the stuff that we do, would be more looking at how do you physically and digitally integrate a vertiport into other transport systems. For instance, if there's road, rail, whatever it might be, and how do you actually integrate it so that it does become it just links to the other transport systems. It's not just a standalone system. And again, it could arguably be reasonably easier to do that at an airport than a brand new facility. But I mean, physically, the standards are developing, and it's something that we can do, and it's an extension of our kind of airport planning business.
Chris, I want to ask you specifically, and thank you before we get started. Thank you so much for stepping in for your colleague on the panel today. Appreciate that very much. But Chris, as a helicopter pilot, how are you viewing the interest in vertiports and the sort of, what are the points of interest for your community in the whole development of vertiports and eVTOL air taxis?
Yeah, thanks, Miriam. And I'm really honored to be on the panel with all these great minds here, moving us forward into the future. And HAI, we're celebrating our 75th anniversary this year. And we've been advocating for the vertical aviation infrastructure for that same amount of time. So just a reminder to everybody that, we've got a great use case in play. It's called the existing helicopter vertical aviation infrastructure. And I think Ty or Ian brought up the point of using the existing airports that are out there. Well, we've got a lot of existing vertiport/heliports that are out there that are also ripe for the picking, good use cases, a fertile ground, if you will, for the integration of these capabilities and scale more quickly, trying out some of these use cases on existing where the battles have been fought and won, as opposed to creating new battlegrounds where, in some places the resistance is pretty heavy. So, acknowledging the hard work of the legacy helicopter industry and using that, take advantage of that, forward looking, celebrating the past, advocating for the past and the present and the future. So, we've got 1,100 companies, 16,000 individual members in 65 countries, and 3 million hours a year of 3,700 existing air vehicles. So there's a lot of folks out there with skin in the game in the vertical aviation industry. There's some resistance of the uncertainty from some of the legacy operators, but HAI represents the vision of looking into the future. And we look forward to partnering with you guys to solving these tough challenges, integrating safe, smart solutions moving forward. So yeah, we're very excited about the expansion, and we want to partner with all of these folks to help find the right solution.
Yeah, I think definitely as I have the opportunity to communicate with this whole sort of community, there's definitely this sense of collaboration and, let's leverage each other's expertise to kind of make it happen. So I want to have a discussion here with Anthony and Ian. Anthony, Supernal is really focused on scaling. I hear the word scaling a lot, right? That is very critical to the success of the industry. Can't do kind of one-offs. So I wanted to have you address some of the implications to digital infrastructure to sort of support digital and physical infrastructure to support exponential growth. And is there room for this concept of leveraging what's already there, leveraging these heliports and the infrastructure that already exists to help scale faster? And I think both you and Ian have, or anybody else, please jump in. Tony, you need to unmute, please.
Sorry about that. Yeah, thank you. Yes, so scaling is obviously a key part of our business plan, right? And obviously, the quicker we can scale, the quicker we can get the price point to where we want it to be and what our plan is to have urban air mobility succeed. I'm not an expert on the digital side of things, but certainly the idea that in order to have that scaling occur, we would need to have some sort of ecosystem in place in order for us to operate in areas that essentially commercial vehicles are not operating today. So that's obviously a huge part of the effort. And then also widespread vertiports around and access to airports where that may be challenging, because many of the airports that we need to operate at are busy and they're very sensitive to adding new operators. So the point being at busy airports that we would not necessarily have the same arrival departure stream coming from a different angle, and then ideally not use any of the existing systems as early as possible by using our own form of system to avoid the issues of the existing air traffic control. So that's a big point, is how do you add potentially thousands of vehicles to a system without having a workload impact on the FAA? And that's sort of an area that we're focused on. And the first segment maybe being, adding sandboxes where we can experiment with these rules. And on the topic of, existing heliports and I think there's existing airports that we would potentially operate from as well. That's yet to be seen. A lot of the heliports are designed for limited use. And this would essentially be a high commercial operation. So going to and from the vertiport on top of the building, for example, would add travelers to the elevator system. We'd need to add a fair amount of infrastructure on the top, the rooftop area. So I'm not so sure that that existing heliport system is what we have in mind, but it certainly is a part of it. It would certainly fit a lot of our existing cases, such as corporate operations and a limited amount of air taxi service to a specific building, but not necessarily the mobility hub per se. So yeah, there's a certain amount of the infrastructure that would be useful, and then we would certainly need to build out through a variety of means wholly new infrastructure capable of supporting scaled operation. And that's where the challenge is how do you get to that scale? What does a scaled vertiport look like? Is it one big place, or is it a variety of smaller vertiports? That's a topic to be considered.
So just to clarify, you're not necessarily seeing the biggest impact of your business is not the private trips from Las Vegas Airport to the roof of MGM. You want sort of more of a public access.
Yeah, for sure. The idea that we would be able to handle the corporate part of that is certainly there. I mean, so we want to have the vehicle have a variety of options available that would appeal to a wide variety of users. But the one that gets us to scale is the air taxi and the connected mobility vision. And that doesn't necessarily involve us going to the top of a building, but would probably be in a separate mobility hub that accommodates a variety of transportation connections.
Okay. And Ian, what are you seeing as some of the critical aspects to the possibility of utilizing or converting existing infrastructure?
I think for airports, it's probably two main sides to it. It's not quite simple, but large international airports or hub airports, that's where the traffic is and the demand is. So you would think that that's where it'd be easy enough to scale, but many of them are constrained physically or their airfield. They're constrained by their airfield, but actually a lot of them are constrained from terminal and landside facilities. So actually physically building a vertiport with say one or two pads is probably you could probably do that at most airports. That's fine, but that's then difficult to scale because you'll need the land. Airports quite often struggle to keep up with the capacity for their terminals, for instance. So they're always kind of not always, but they're often behind in actually building out the capacity they need. So to then try and scale up an entirely new kind of mode of transport, a new business into that environment is going to be quite difficult to sell to those who are making the financial decisions at the moment. Other side of it would be smaller airports, smaller regional airports, perhaps with lots of capacity, lots of land that they don't know what to do with. But then again, where is the demand for AAM there? Could you actually scale that from a demand perspective? You've got the space, but you might not. So it's like the other way around. You've got the space, but you might not have the demand. But then again, maybe this is going to stimulate demand. So you could definitely use. There's many airports, probably helipads that you could adapt or develop or introduce AAM into today. But I think at the larger airports, it's perhaps difficult to scale that at the moment. That said, if once airports start to see that this is or if they start to see that it's a very good source of revenue and it is a good commercial venture, they'll find a way of doing it. They always do. Airports are very adaptable. Aviation's always fast. It's always quick to adapt and move on. So it might seem hard now, but maybe it actually isn't, because there's you could be a bit more creative, for instance, and build some facilities on the top of car parks or whatever it might be if you don't have the space around the airfield. So yeah, I think, as everyone else has said, I think using existing infrastructure is being used today. That's what we are doing today, and it probably will continue for the next phase, however long that will be, of the industry, and we can continue to do that before we start needing to expand physically expand the boundary of large international airports, as an example.
And Ty, I could see your yes, I could see on your face as we were talking about this idea of leveraging existing infrastructure. What are your thoughts about that? Because presumably you're not handing it over from one type of aircraft to another, right? You're adding. So
right, yeah, integration. That especially as a professional helicopter pilot too. This idea, the trauma centers, the burn centers are all in the city for the most part. And so the volume of traffic and all that has to allow for, manned aircraft that are operating on the legacy national airspace system and air traffic control system to, penetrate, that buzzing hive of traffic serving that urban area to get patients to where they're going. And so that will always be part of it. Integrating is certainly the goal, and that's what has to happen. And I was just kind of sitting there, as people were talking, and in the late 90s, NASA really put a lot of thought and a lot of time when things like the V-22 Osprey, were finally coming to maturity. They thought tilt rotors were going to revolutionize transportation in the way finally that it looks like urban air mobility will. And so they really put a lot of intellect into solving these problems we're talking about now, and even some creative solutions like building passenger terminals, et cetera, and the clover leaves, in the center portions of the clover leaves and all that. And so I was just kind of as people were talking, thinking about some of those older ideas and wondering how much of it would still be applicable. But I thought too, as Ian was speaking, that the benefit of this technology is that it can land and take off at places that are not airports. Just like a helicopter, I land next to the swing set in somebody's backyard, right? I don't need a heliport to up. I land in the middle of the interstate. And so I was kind of wondering, if this will be a disruptive technology, and so maybe people will be renting less cars, et cetera. So if you could take over some of the parking lots and a grass field, this kind of thing, and make sure the dimensions and all that are appropriate, and if it's close enough to where the rental car place was, well, then it's convenient enough for people to use it as a transition mode of transportation to wherever they're going. But that's if you were reading that on my face, that's what I was kind of thinking about.
Yeah, no, definitely interesting perspective there. So I want to kind of move to this area, which is always sort of fascinating to me. And Brent, I know ANRA has been really at the forefront for as long as I have known Amit and the company of forming these partnerships. And what I'm getting to is, this is an absolute example of a new technology which cannot develop itself. There are so many aspects of this. There is the physical infrastructure. There is the vehicles themselves. There are the flight paths. There are the input from existing manned aircraft, which are already which are carrying 100% of the load really now for these transportations. And then there's the digital component. So how do you see this, Brent, this need for partnerships and as we sort of develop the standards and we develop the infrastructure and we kind of move beyond individual test flights?
Yeah, thanks, Miriam. So we're getting a little bit of a demand signal from end users that have asked the question, how do we start down this road with advanced air mobility with eVTOLs? Where's the playbook for installing this and implementing this technology in a local jurisdiction like a city or a municipality? And so there's a lot of questions being asked, and in parallel, there's a lot of activity that would help these individuals take the next step on this journey. But very few, I don't know if there's a turnkey solution that exists out there. And because we're still very much in the early stage of this industry, we're still developing standards. The regulatory environment's not quite stable, and that's internationally. And so there's a lot of things happening in parallel. And so as the technologies or developed in parallel. It requires us to collaborate. And so ANRA's in the United States under the FAA and NASA concept of operations, we're called a provider of services for UAM, or PSU. And that allows us to move air vehicles through time and space using our software when they're connected. And then we share that information with the broader ecosystem when I was talking about earlier. And so being able to work with OEMs to understand what does that mean when we integrate with the aircraft, to be able to work with the infrastructure providers and understanding how do the individuals that are flying these aircraft, the fleet operators, get to the destination. It's important to be able to collaborate with them. And it's important to collaborate with those who recognize near-term implementation will take incremental steps, low risk, crawl, walk, run type of implementations. You were referring to near-term, let's use today's infrastructure. So everything I described requires us to collaborate. And then in doing so, we recognize, well, partnerships will help walk into the door and say, we don't have the entire solution, but we have a pretty big piece of the solution as it sits today with the level of maturity that we have today, so that we can start creating a sandbox. And so you may have seen that Navos, Ty, the impressive pilot on the panel, we formed a partnership to be able to take what Ty does and with what ANRA does on the digital side. So Ty's out there flying his impressive helicopter to help identify the approach procedure to and from a sandbox vertiport. And then we would take Ty's information and we would layer it into our software so that when we start to manage these aircraft, the fleet operator sees that it's coming from an en route destination and hitting an approach fix that Ty has developed, and then they can monitor the flight path to the ground. And so that's just one example of thousands of examples that we would be able to elaborate on partnerships to include Supernal, our VMS, a vertiport management system that we are have developed. Now we're tweaking it for Supernal's implementation for what they envision for their concept of operations and so on and so forth. And we've worked with Ian in the past on other proposals and opportunities. And so you can see that not one individual on this call, maybe are also from the people that are listening on the call, it would take partnerships and collaborations to be able to bring and move this industry forward.
I want to address sort of another very impressive pilot, of course, on the panel, Chris. You know, we're talking about sort of developing this new technology, this whole new thing. We're talking about partnerships, and certainly, as you pointed out, 70 years the helicopter pilots. You know, the helicopter industry has been working to develop new technology and integrate into the airspace. So what do you think that the eVTOL industry and air taxi industry, advanced air mobility, so to speak, has to learn from the helicopter industry? You know, how can those partnerships really boost the growth of the new?
Yeah, thanks, Miriam. Yeah, everybody's touching on it really well here already. Thanks for that, Brent. The one thing I think that, you know, just exploring the same path that helicopters have taken and knowing where the pitfalls, where the roadblocks, that sort of thing, onerous regulatory oversight, you know, all of those barriers have been navigated by the legacy, traditionally piloted aircraft industry and the vertical aviation. So partnering with, you know, these legacy operators and stakeholders and the service providers, you know, understanding the challenges, how they push past them. I like the idea of the old stodgy, overly conservative, safety-minded world. You know, I'm a safety guy, but merging that with the agile, fail fast, you know, techie, you know, industry. A lot of people don't like the blending of those two worlds, but I think we can look at it from a positive angle and say, hey, both sides can learn something from each other, to where we don't have to be stuck in the old stodgy way of thinking. There's new ways of exploring this new pioneering technologies, and you know, like integrating some of these great technologies that are out there in these new air vehicles into legacy aviation aircraft, where you can't get the certification to get the full air vehicle in the air with passengers, but some of that capability can be inputted and integrated into existing legacy aircraft. There's examples of that where we have, automated flight controls, alternate flight controls. We've got digital pilot, clearances, things of that nature. A lot of this UTM capability that's out there could be tested and proven and refined and fixed 3 layers in before potentially we're going to get the right clearances from all the state regulators that are out there. So I think a very tight partnership working and advocating for integration of the new technologies in existing air vehicles is a good path forward while simultaneous efforts continue on the new evolution of aircraft.
That's a absolutely fascinating answer. Actually, I think the concept of sort of testing some of the capabilities on traditional aircraft is really interesting. Also, it is demonstrated by this panel here, right? Most of the players in the new technology do come from a more traditional manned aircraft area. So interesting answer there. Okay, I want to ask a question here, Tony, and not trying to put you on the spot, but you mentioned when we were talking about scaling, you mentioned trying to sort of work without requiring anything from existing FAA infrastructure because, you just have to read the headlines. That's strapped, right? There are problems there, and I'd like you to sort of talk about is that a reasonable goal? Can this new industry just say, okay, we won't put anything on you guys. We know that you're already overloaded, or do we need to be saying, hey, look, we have future real benefit to communities and the aviation system and the country, and we need you to invest with us?
Yeah, so the comment that I made had to do with, we won't impose additional workload, in the areas that we transition from the city environment to the en route phase, and also at airports directly, right? So I think that is essential in order to speed up the timeline. So our interest is in scaling, and not only scaling, but scaling as quickly as possible. So a lot of these restrictions that exist and that ultimately kind of kill off some of the industry that was available prior needs to be dealt with kind of head on. So the quicker I think we're able to demonstrate to the FAA. So I think it ultimately comes down to what are the core roles of these different agencies and what are they supposed to do, and using that in order to kind of create this sandboxing where we can experiment and adapt. And I like the other comment where the technologies then translate upwards into a variety of other industries, including traditional aviation, and these are deployed to solve other traditional aviation problems, which is why there's a lot of investment in UAM also to solve other problems. I think the quicker we're able to start to go down the path, and that's where I wonder is are we trying to make slight modifications to the existing system in order to accommodate a novel approach, or are we is it about time to stop kicking the can down the road and think of a more holistic approach to streamline the transportation system in order to make the whole entire system efficient and get out of these sort of protocols that we're all in, because of what we're creating is essentially an interrupter of automotive more than it is of aviation, right? So, trying to recognize that and then adapt accordingly. I think the quicker we get to the point where we change the existing system to account for the future of transportation, the better off we'll be in the long term. And in my mind, this isn't a supernal, official opinion. I think that involves the stratification of the air system into altitude segments, and do the same thing on things like radio and satellite waves and bandwidths and cellular and so forth in order to accommodate these changes. So to me, the quicker we get to that point, the better overall we will be on creating a more sustainable world.
Right. So there's pragmatic approach to just making it happen as quickly as possible.
Yeah. So all that said, I think we're interested in, I think we're going to be forced to operate within the constraints of the existing system. I think we want to prove to the FAA and other worldwide regulators that the system is safe and efficient, and that we can use the standards that those organizations make, and then adapt them to our vehicle and our business approach. And then from there, it's going to have to be incremental, but the incremental part needs to occur more quickly. And how do we get to the end goal? So, so for example, this whole entire concept is not new, and we more or less are applying the FAA and NASA criteria, and we're also applying the next gen principles, which are now over 30 years old, and yet we haven't had the wide sweeping changes that are needed in the aviation system that were envisioned decades ago. So it's time to implement some of those.
Okay. Thank you for that. For everybody watching, the Q&A has now been turned on in the lower right-hand corner of your screen. Please do put any questions that you have there, and we will get to as many of those as we can. So moving on, Brent, I mean, this is sort of speaking the obvious here. We're at the very beginning. And from what I'm seeing out in the industry as aircraft, new concepts of aircraft and so forth come across my desk, we are talking about initially piloted aircraft, but many of them do have the facility to become uncrewed at some point. That's how drone life was started 13 years ago, so we might have chosen a different name if we had to do it today, but that's how we get into that. But so how do you see this, concept of maturity? How is this digital layer going to keep increasing support till we get to the point where we have, uncrewed eVTOL systems?
You're right. We're still relatively immature in the industry, especially on the digital side. So understanding all the interoperability requirements to share this digital layer with all the actors. And one challenge is getting all the actors together to be able to figure some of these technical challenges and solve some of these problems. And so there's a couple different areas that need more focus. And when we were testing in California this past summer with the FAA, we recognized when we were flying between two airports, San Martin and Hollister, we created a corridor for a couple of OEMs to fly in, and we provided the services to manage the aircraft through those corridors. And the FAA they were there with their air traffic control and engineers. And one thing that we soon recognized is we haven't quite solved the corridor spacing problem on how to use performance-based characteristics on assignment of how and where these aircraft can pass. Just think of a highway and passing lanes. Do you go above? Do you go behind? And the distances between, one's going faster, one's going slower. So you have to manage that traffic flow, which happens every day in today's air traffic system. So that digital layer, as an example, shows the complexity and what we need to continue to solve. And we realized in this evaluation with the FAA and their engineers, if one of those aircraft should happen to pop out of that corridor, and that corridor wasn't being managed by the FAA, that was completely internal to the system that we would manage as a digital provider. But what if one of those aircraft were to pop out for whatever reason, and then also enter the rest of the NAS, the National Airspace System? And so the separation that's being provided by the rest of the FAA is all of a sudden not there any longer because you have to deal with this new aircraft that wasn't part of the original plan. And so how do we manage not only the digital layer inside of our own urban air mobility world, but then how does that digital layer gets transferred and then understood by the rest of the world, so that when you have these anomalies or these different scenarios, and I can go on about a number of different scenarios. So with that, we're working on those different areas, and we also recognize there are gaps within their own layers. And one of them is this: how do you get to the vertiport? And so More work to be done. We're happy that there are standards being developed to help point to means of compliance and allow the industry to build towards those standards so that we can have even better interoperability.
Okay, we do have an interesting question that came in. I'm going to get to that in just 1 minute, but Tony, I wanted to ask you a question kind of related to this, and you were kind enough to send me this in pre-show, and I really thought this was interesting. Is what are the other challenges? Brent just mentioned, as this digital infrastructure is being built out, what are the other challenges affecting digital infrastructure build out from your perspective, from the aircraft provider?
Yeah, it's definitely an open-ended question. One of the challenges that I think that I wonder about is, we're focused on our vehicle and our system, right? But at the same time, we also believe that the whole entire system should be open access. And so what we don't want to see formed up is a variety of privatized areas such as corridors and vertiports, and that essentially limits access later on and creates wholly new barriers, right? So adapting the system, and that would include the stuff we're working on to accommodate a wide variety of users, a wide variety of vehicles, all operating on the same platform, is the ultimate goal from our point of view. And I kind of think we're all scurrying around and sandboxing our own ideas, which have a lot of similarities. But then how do we kind of bring it all together? I think it's okay, the situation that we're in, but ultimately we need to kind of bring it together and say this is how we're going to operate a connected and integrated system. And one other slightly divergent point to that whole thing is that we're, I think that this industry, we keep talking about integration into the mass and all that. I think if we follow anywhere near the trajectories that we think we might, we're talking about an overtaking industry. Part of the reason why I push back on saying things like, should we start over on our system design, and when do we do that versus try to change? Because on the forecast that various OEMs have, we're potentially going to have a lot more of these aircraft operating in the world than we do on traditional aircraft side. So on that point of view, it's like the automobile. It's an overtaking industry. So should we be using old standards that accommodate traditional aircraft, or are these aircraft the future traditional aircraft, where the other ones are more rare? So it's that quandary that I think it's worth taking a little bit of a thought into, and look at a bigger picture of the future. And I think maybe that time has come.
So that's the perfect lead in to we have several questions now to address, but and this is really for anyone here, is why are we doing this? What's the significant driver creating the need for an expansive, integrated, and connected infrastructure in low altitude airspace, given that we have millions of hours of helicopter flights currently? So I think this is something that we need to clarify many times, really, is what's the difference here between what an eVTOL can do versus what a helicopter can do? Who would like to take that one?
I guess I can start. I think that the difference from most of the eVTOLs, particularly ours, is the idea that it's connected mobility. So as we build out, it's a crawl, walk, run, but hopefully a shorter duration of each one of those. But ultimately, we're envisioning a combined connected system that gets you from point A to point B, and ultimately allows people to. It's an overall automotive trend where people own fewer and fewer vehicles, and increasingly we're selling the transportation as a service. So that's a trend that we think is already happening today, and that is going to be in the future. And it affects, our outlook for selling automobiles, for example, on how to continue to to evolve the company in order to accommodate this shift in demand, which could be generational and so forth. But that's ultimately what I think we're trying to solve here. So eVTOLs offer that connected capability and these advanced technologies that connect ground vehicles with air vehicles, and that's a use case that's not necessarily being done with a helicopter today. And then we don't solve all the helicopter challenges either. That's not the intent.
Right. And so I do want to specify for the audience, because I don't think I mentioned it, Supernal is a division of Hyundai. Is it a division or I may have said that wrong, but it's
an affiliated company.
An affiliated company with Hyundai. So as Tony mentioned earlier, they are sort of viewing this as a replacement, not necessarily for other aircraft, but for, some of the automotive transportation needs. Okay. Anyone else want to touch that one? We actually have quite a few questions coming in now. So, what will digital infrastructure additions do to landing fees and ticket prices? It's assumed that in a privately developed ecosystem, all costs have to be captured. Is this a privately developed ecosystem? Or is that sort of yet to be determined as the market speaks? Anybody want to?
Yeah, I think it's the latter. I think it's premature to pin it down, but I think we're assuming it's going to be both private and public. And we assume that, like all services provided today for what we enjoy in today's airspace system, when you climb aboard a United Airlines or Southwest Air, there's a cost associated with being able to provide those services so you can fly from point A to point B. And largely that's airspace system that we enjoy is paid for by the commercial airliners and fees that they are taxed to provide. And so it's not yet clear by most regulators that I'm familiar with internationally on how this new system will be similarly taxed or provide and buy into that airspace services that they will enjoy to be able to fly their urban air mobility from point A to point B. And so as an enabling technology, the digital services, and it's more than just the software that I'm describing and we represent at ANRA, but it's also things like weather and things like surveillance and command and control. And there's a host of other supplemental data that goes into enabling these missions. And so each one of these service providers, as a business, as a third party, we're trying to figure out how to monetize that so that we can stay as business and provide these services. And so a lot of these challenges are not yet clear. Some of it is driven by the regulatory environment, some of it mostly by the market. And so as it matures, I think we'll be able to start to identify, are we going to now ask for a per mile fee, or are we going to ask for a per passenger fee? We don't know those numbers yet and how we're going to derive revenue.
Okay.
Can I add something there, Mary? Sorry, I just haven't had much time. This goes to the point of many, certainly passenger use case or people movement, trying to make AAM an equitable, make it equitable to all, and perhaps progress social objectives and maybe economic objectives. I think this could be a clash at some point between who pays for this, because does there need to be market intervention, for instance, to actually, because no, it's going to be very difficult to, for example, to argue that you need public money, for instance, to launch an AAM service, because you need to pay for all the other things that Brent's just mentioned, as opposed to then not funding some other, making it up, but a local bus route or something. So it's a very fascinating question, which I think could start to be in conflict once if everything's just left to market forces. The social and equity objectives of AAM might be more difficult to achieve.
Okay. Thank you for that. That's a very interesting question and a way to think of it. We are reaching the end of the hour here. I appreciate everybody's time so much. We do have a lot of questions coming in, so I want to try to take at least just one more of these questions. And again, for anybody, do you see the size of eVTOLs increasing to carry larger payloads, as we saw in the development of traditional aircraft? So, we started out with two-seaters, and now we have jetliners. And do we see that? Or again, to go back to Tony's earlier point, are we still we're really talking about what you could do with a car, not necessarily what you could do with an aircraft?
Yeah, I guess I can start out with this. I mean, I think we'll adapt to the changes in market demand and see how things work. And it's probably too early to tell, exactly what all the use cases are, what sizing are needed. It might even be that smaller aircraft, fewer seats might be a better option. So it's unknown, and I think we're preparing for a varied approach in the future.
Great. All right. Well, we are reaching the end of the hour. If I could ask each of you just very quickly, 30 seconds, 20 years in the future when we have a much more mature platform to be talking about, how do you see eVTOL changing your immediate everyday life? Brent, you want to go first with that?
Accessibility. I think we're going to go places we hadn't dreamed of before.
Chris, what do you think?
I think there'll be a combination of traditional and remotely piloted aircraft. Dull, dirty, and dangerous will probably sneak into that space as much as possible, given the power limitations and weight and, the traditional safety margins we look for in traditional aircraft. If they can crack that code, I think we'll see a big emergence.
Tony?
I think that the trends are going to continue towards mobility as a service, where fewer and fewer people operate their own vehicle and then choose to use their devices to get around and order services, as they're increasingly doing today. And that will ultimately start to have us question and change and adapt to a more sustainable future, such as having fewer lanes of highways being developed and allowing us to repurpose some of our parking garages and areas that take up a lot of space inside cities in order to create a better city environment. So it's an overall change of our outlook of our city environment, the world, and how we're using the resources we have.
Ian?
I think it will start to. I think we'll start to normalize it, so it'll become normal to step off an aircraft onto AAM aircraft, and then onto a train, or vice versa, and it'll become in some cases, just an integrated form of transport, really, and it will become perfectly normal to do it.
Ty?
Yeah, kind of like Ian was saying, I think autonomous cars, trucks, etc., will certainly normalize hopping in the vehicle, with no driver, not putting your hands on the wheel, which will facilitate, people being comfortable with hopping on an aircraft in the same way, especially with pilot shortages, nationwide and this kind of thing. Autonomous aircraft will certainly be a reality within the 2 decades.
All right, and I'm just going to put in my last 2 cents, which is honestly for me, I think a lot about accessibility too. Just if you think about all the people to whom driving a car is not available right now for whatever reason, autonomous vehicles help them to get where they're going in an independent fashion. So, all right. Thank you all so much for participating in this discussion. Really fascinating. We are, of course, at the very beginning of this industry, so I'm looking forward to 10 more years of fascinating discussions as it moves along. Thank you all to our participants for being with us. This episode has been recorded, and it will be available to you on the Drone Life YouTube site in the future. Thank you very much.